This is Algebra 2, Chapter 0, Section 3, in which we will be factoring polynomials. A skill set that you probably already have, you just need to have refreshed a little bit. A lot of times when we're doing problems in algebra, we need to be able to factor in order to get to solutions. And the first step in such problems is always to look for the common factor. I'm going to flash that at you so that you see how important it is. Look for the common factor. Most of the time when people miss a factoring problem is because they haven't looked for the common. So let's find a couple of common factors here. What's in common between 4a squared and 8a? 4 goes into both, and a goes into both. So 4a is the common factor. I'm going to put that on the outside. And then if we divide 4a squared divided by 4a, that leaves a. 8a divided by 4a leaves 2. A way to check your problem or your answer to make sure you got it right is if you distribute that back out, you should get the original problem. Let's look at another one here. 6p cubed plus 18p squared plus 6p. They each have a 6 and they each have a p. So 6p is the common factor. If we take 6p out, divide it out of 6p cubed, it leaves p squared. If we divide out of 18p squared, it leaves 3p. And if we divide out of 6p, 6p divided by 6p is 1. A lot of people make the mistake of not putting that 1 as part of their answer. If you don't have something there, you can't distribute back to get where you started. You need a 1 to be able to distribute by. A nice thing to look at, if you had 3 terms to start with, you should have 3 things inside your parentheses also. So I'd like for you to pause here, take a look at this problem. 8y to the 4th minus 32y third minus 4y squared. Pause here, work it, then come back and check your answer. The common factor in this is 4y squared, and when you factor that out, it leaves on the inside 2y squared minus 8y minus 1. Okay. Another kind of factoring we're going to do a lot of is factoring trinomials. And the best way I've found to do these trinomials is to use what I call the magic sentence. We need factors of blank that blank to blank. Okay. When I talk about this in class, when I'm walking around helping you or whatever, you're going to hear me say very often WNFO. We need factors of. It's just a shortcut so I don't have to say all the words. WNFO. It sounds like a radio station, but it's not. It's tipping you off to what kind of problem you're working on. So let's see how this thing works. We have x squared plus 7x plus 6. The sentence goes like this. We need factors of the last value, provided this is a 1 in front. There's nothing else here. We'll do a couple about that later when there's something there. But for right now, we're just going to have a 1. So factors of that number, 6, that add the sign in front of the 6 to make 7, the number in the middle. We need factors of 6 that add up to make 7. Well, the factors of 6 that we could find are either 1 and 6 or 2 and 3. 1 and 6 add up to make 7, so those are the 2 factors we need. To make x squared, we need x and x. And then 6 and 1 were our 2 numbers, so x plus 6, x plus 1. To make a positive 7, we need positive 6 and positive 1. Just like before, if you distribute this back out, you should get the original problem. That's a nice check to see if you're doing it right. Let's try another one here. D squared minus 8d plus 12. we need factors of 12 that add to make 8. Now some people would put -8 here because it's -8. I don't. I worry about the signs at the end. If you want to use -8, that's fine with me. Factors of 12 are either 1 and 12, or 2 and 6, or 3 and 4. Of those, the only one that makes 8 is 2 and 6. We want d squared, so we need a d and d. We need a -8, so we need a -2 and a -6. Okay. One more of this kind, and then I will let you try one. We have f squared plus 14f minus 15. Well, we're still going to use the same rule. We need factors of 15 that, in this case, subtract to make 14. Subtract because it's a minus right here. Well, factors of 15, there aren't that many. 1 in 15 or 3 in 5. Okay. Of those, the only one that subtracts to make 14 is the first pair, 1 in 15. We want to make a positive 14, so we'll need a positive 15 and a -1. So f plus 15 times f minus 1. I'm going to ask you to pause here and try this problem. Don't let these g's throw you off. Okay? It still works the same way. You're just going to have a g as part of your back end of the parentheses. Give it a try. Come back in a couple of seconds here. See how you do. So we're going to need factors of 12 that subtract to make 4. Well, that's 1 and 12, or 2 and 6, or 3 and 4. 2 and 6 are the ones that subtract to make 4. We want -4, so I need a -6 and a +2. H squared tells me to put h and h. The g squared tells me to put g and g in the back with the numbers 2 and 6. Okay. Now when it gets really fun is when there's a number here that's not 1. It still works the same kind of way, we just have to tweak our strategy just a little bit. So instead of saying we need factors of 3, we're going to multiply the 3 and the 6 together. So we need factors of 18 that subtract to make 7. Well, our factors of 18, there's only a few choices, 1 and 18, or 2 and 9, or 3 and 6. 2 and 9 subtract to make 7. So they're going to be the numbers in the right-hand part of the parenthesis. Since there's something in front here, we're going to have to work with that. And the way I like to do that is I put the 6x in both places. So 6x plus 9, 6x minus 2. Now I know if I distribute that, I'm going to get 36. So I need to reduce these factors. Whatever I can do to reduce it, I'm going to reduce. This one has a 3 in common, so I'm going to divide out a 3. And it leaves 2x plus 3. This one has a 2 in common. 3x minus 1 is what's left. I divided by 3 and then I divided by 2. That's the same thing as dividing by 6, which is what I was extra to start with. 6 times 6 was 36. I was extra by 6. I've divided out that extra 6. Give you a few seconds here to try this one out. 9r squared minus 6r plus 1. Pause the video here, try this problem, come back and check your results. So here we're going to need factors of 9 that add to make 6. Well, factors of 9 are either 1 and 9 or 3 and 3. 3 and 3 add to make 6. We want -6, so it'll be -3, -3. So you have 9r minus 3 and 9r minus 3, again bringing 9r from both of them. Reducing, we can take a 3 out of here, and we can take a 3 out of here. 3 times 3 is 9, that's what we were ahead by. So we've divided that out, we're all good. Dividing by 3, we get 3r minus 1 and 3r minus 1. Okay. We have one last kind of problem to look at. We have to look at the difference of two squares. If we have a square in the front and a square in the back and a subtraction, it has to be subtraction for this to work. If it's addition, you can't do it. Then we can use the rule for the difference of two squares. X squared is x times x, y squared is y times y. So we can put an x in both fronts, a y in both minuses, and then 1 plus 1 minus. And you can do it either way. The negative can be over here if you want it. I'm a positive optimistic person, so I put the plus first. Okay. Let's try this one on. 9x squared minus 4y squared. Well, 9 is 3 times 3. X squared is x times x. 4 is 2 times 2. Y squared is y times y. So everything is a square, and it's a minus in the middle. We're in business. 3x and 3x, 2y and 2y, 1 plus 1 minus. Now this next problem, 8k squared minus 18, I'm going to remind you what rule number 1 is for factoring. Look for that common factor. If you look closely here, you see there's something in common, a 2. So we'll take the 2 out, and we get 4k squared minus 9. Well, 4k squared is a square, 2k times 2k. 9 is 3 times 3. So we're in business. 2k plus 3, 2k minus 3. And the 2 that we brought out to start with, that we factored, stays outside there. So we'll ask you to pause here, try one more problem, look for that common factor, and then come back after you pause, work the problem, check your results. Hopefully you found your common factor was a 9. So you take a 9 out first, and that leaves you 9y squared minus 1, which is a perfect square, 3y plus 1 and 3y minus 1. Difference of two squares, I should say. So a lot of factoring pieces, a lot of different things to throw at you, but they're all skills that you've had in the past and you just need refreshed on. As always, if you had questions, hopefully you wrote those down, and you can bring them in, and we will see you in class.